Hello, my name is Shreya Mehrotra, and in this video, I will walk through software development on the Nios V processor using the open source ecosystem. The Nios V processor enables access to a diverse ecosystem, and you can choose from modern IDEs, compilers, debuggers, and operating systems. The current software development flow for Nios V has been tested with the Eclipse IDE, which is what I will be using for this video. But you can also use a third-party development environment of your choice for software development.
In this video, first I will show how to easily generate a BSP in Platform Designer with a one-click button. Then I will generate and build a Hello World application, and finally I will run Hello World on the Nios V processor on the ARIA 10 SoC development kit. A board support package, or BSP, provides a software runtime environment for embedded systems such as Nios V processor systems. To generate a BSP, in Platform Designer window, go to File, New BSP. The Create New BSP window appears. For BSP setting file, create a BSP folder in the software directory and name the BSP as settings.bsp. For system file, select the Nios V processor Platform Designer system, system.qsys. For Quartus project, select the example design Quartus project file or top.qpf. Select the operating system as Altera HAL or Micrium Micro COS 2. Click Create to create the BSP file. Click Generate BSP to generate the BSP file. You can also generate the BSP using command line instructions. For details, please refer to the Nios V Quick Start User Guide. The next step after BSP generation is generating the application project. You can find the Altera HAL application source file hello.c in the software/app folder with the generated design example. If you selected Micro COS 2 during BSP generation, please replace the application source file hello.c with hello micro COS 2.c.
You can find instructions on where to find the Hello Micro COS 2 C code in the Nios V Quick Start Guide.
Launch the Nios V command shell. Execute the command as shown here to generate an application cmakelists.txt file. The next step is to build the application project. You can do this either using the Eclipse embedded C++ development tooling or the command line interface. For this video, I am using the Eclipse graphical user interface to build the Nios V application. Launch Eclipse. Select or create a workspace folder and launch. You will also need to install CMake for Eclipse. The easiest way to install the Eclipse plugin is to drag the Install button over to an Eclipse open instance. You can also manually download and install the zip file. Go to File, New, C++ Project. In the dialog, choose C++ Managed Build. Point the location to your app folder and select CMake Driven Empty Project as the project type. You may need to uncheck Show Project Types and Toolchains for the CMake Driven Empty Project to be an available option. To modify the project settings, right-click on the app folder and select Properties. To set up the toolchain paths in your system or user paths, please watch the video on setting up open source tools for Nios V processor. Alternatively, you can follow instructions in the Quick Start user guide to set up the toolchain paths in Eclipse. Under CMake for Eclipse, select Host OS Overrides and select the build script generator to Unix makefiles if you're using Windows. Click on C++ build and set parallel compilation to use optimal jobs since the default is use unlimited jobs, which may slow down your computer on initial compilation. To build the project, go to Project, Build All. The console window will show the status of the build. When the build is complete, the ELF file will be generated in the build/debug folder. After generating the ELF file, we will program the SOF file onto the FPGA device using the command line. For this video, I am using the ARIA 10 SoC dev kit. We will download the ELF file on the Nios V M processor using Nios V download command and then reset the CPU with a toggle ISP tickle script that is in the Nios V M example design folder generated from Platform Designer. Finally, after programming the Nios V processor and the FPGA, we will execute the JUART terminal command to display the output. To learn more about the hardware and software application development on Nios V M, please watch videos Part 1 and Part 2 that talk about the Nios V M processor in Platform Designer and setting up open source tools for software development. For technical details, please read the Nios V Quick Start User Guide, and you can also refer to the Nios V Eclipse setup on rocketboards.org. Please contact your sales representatives for support.